All right, so we're going to start off by multiplying in the exponent. Whenever you have an exponent on the outside of parentheses, you can just multiply exponents. So you got a -4 times -3. You got a +12. You got a 2 times -4, -8. And I'm going to do the same thing down below. -2 times 6 minus 12 x to the -4. So we have a -2 times -4, +8. So from here, negative exponents, you can cross the line, change the sign. So that means we're going to end up with this right here. And from here, we can simplify to this right here. All right, so let's go ahead and do B. We're going to first simplify the insides of the parentheses before we multiply them together. Alright, so I've simplified the inside of the parentheses and I'm ready to multiply. And I got a 4 over a 2. That's going to give me a 2. 2 times 3 is 6. And a squared over a gives me an a in the numerator. And then, let's see, I have b squared times b squared down below. That gives me a b to the 4th power down below. Let's do part C. With these problems, the easiest thing to do is simplify the inside of the parentheses first. So I'm going to deal with my negative exponents to start, and then I'm going to simplify what I can. Okay, so from here, now I've dealt with my negative exponents, I'm going to start simplifying. 10 over 2 is 5, x to the 2nd, x to the 3rd, x to the 7th, x to the 12th. And then I have 2y's over 4y's, which means I have 2 down below. And then we have to multiply in that -2 to each one of these exponents. So we have a 5 to the -2, x to the -24, and y to the -4. And let's deal with the negative exponents. And there's our final answer. All right, so one little note, don't make this stupid mistake that a lot of people make. This is not true here. Not true. A lot of people make this mistake. You can only multiply in your exponents when you have separation with multiplication, not addition or subtraction. This would actually be equal to this here. Alright, so let's move to the second. Okay, so the second problem here, we have to find the standard equation of a circle, which I've given you right here. And all we need to do is plug in. So I'll show you that. Okay, so there it is, plugged in, and you can see it's essentially the opposite values of the HK up top there. So this standard equation of a circle is essentially the distance formula. Also, distance formula comes from Pythagorean theorem. We can talk about more of that later on if you need it. All right, next problem. Okay, so for the next problems, I'll go ahead and explain 3A first, and then B. You want to rewrite without using the absolute value symbols. So 4 minus the square root of 5 is the same thing almost as saying 4 minus 2.23. Well, that's going to give you a positive number, right? So whatever would come out of there is going to be positive. So you could rewrite this problem just by putting the just by writing 4 minus square root of 5. All right, this next one here, pi minus 4, you got 3.14 minus 4. That gives you a negative value, and so essentially you're going to end up with positive 0.86, but you got to figure out how to write 0.86, a positive 0.86 with just the 4 and the pi. So if you flip the 4 and the pi around, that's going to give you a positive 0.86, right? And so you can rewrite this problem without the absolute value just by writing 4 minus pi, because that's just like saying 0.86 pretty much. So I know I'm jamming. I'm on limited time here, so hopefully that made enough sense. Ask me later if it doesn't. All right, so next problem, we got the distance between these 2 points, and I just have the distance formula for you up here, and I've just plugged everything in to show you how to use the distance formula. But it's helpful to know that the distance formula literally is just pretty much the Pythagorean theorem. When you're finding the distance between these 2 points, you're looking for the shortest distance, but you could make a triangle out of this, a right triangle, where this side here represents son of a gun, sorry, that's a 2, so that should be a 5, so that's actually 106. Sorry about that, and I'm catching my error because I was using the Pythagorean theorem here. Alright, so this is 9, so remember a squared plus b squared is equal to c squared, right? And so you'd end up getting the same exact thing. So, alright, let's jam. I don't think I'm going to do this one with you right now. It's going to take too long. Okay, so this one here, we got to figure out the our answer in interval notation. We got to solve for x basically, and so I want to get rid of those denominators. So I'm going to multiply by the least common multiple of the denominators, which is an 18x. So I'll show you the next couple steps in a sec. Alright, so multiplying both sides by the least common denominator is what it's called. We were able to get rid of our denominators, which makes the problem a whole lot easier. Okay, so I've shown you here how to find the inequality that represents the solution set, and what that means is all the x values that are less than 4. Less than or equal to 4 means everything in this direction. In interval notation, that would represent every value from negative infinity all the way up until 4, and you include the 4. The bracket means include, a parenthesis means not including. Parentheses are always used with the infinity sign, and things are always read from the smallest to the largest, going left to right. Alright, next one. Find the equation of a line that contains the 2 points. We want to figure out what y equals mx plus b is equal to. And so we need to figure out what the m value and the b value are equal to. We need to first figure out what the slope is, which is the m value. Okay, so I found the slope, and I plugged it into y equals mx plus b. And now I need to use either this point or this point to plug in and find the b value. It doesn't matter which one you use. You just have to be consistent. If you use -2, you have to use -4. You have to use that single point. So let's see what happens. So I plugged in that first point, solved for b, and then I plugged back in to find out what the equation of the line is equal to. Okay, so for this next one, we want to find y equals mx plus b for the equation that goes through that point is perpendicular to that equation that I've solved for y. I solved for y because I need to figure out the slope. Perpendicular lines have negative reciprocal slopes, so that means that the equation of the line that we're trying to find has a slope that is -2/3. So all I've done is taken this slope here, flipped it, and changed the sign. Perpendicular, negative reciprocal slopes. Parallel have the same slope. Alright, so I'm going to plug in the slope along with the point to find the b value. Alright, so I plugged in the point and the slope, solve for b. At this point here, I had to get a common denominator. The 3 is over the 1. I needed a denominator of 3, so I multiplied by 3/3. I got a 9/3 now, which is just a fancy 3. And then 9 minus 2 is 7 over the same denominator of 3. That's the b value. So in the end, we have our equation of our line right there. Alright, next one. We have to complete the square to solve for x. This one might be a little bit over what you need to do, but what you want to do to complete the square is you want to isolate the x terms. Additionally, when you complete the square, you can't have a coefficient other than 1, so we're going to divide by the 4 there. We're going to get rid of the 4, and so we have this here. And we have to complete the square, which means we take half of the value right next to the x and raise it to the power 2. So half of 2, take the 2 over 2, raise it to the power 2, and that's the value that you have to add on both sides in this case. Okay, so I added 1 to both sides. I got a common denominator here on the right, and so on the right I have a 13 over 4 now. And to solve, and by the way, this is now a perfect square trinomial, which enables us to factor into two of the same binomial, x plus 1 to the power 2. So now, solving for x, square the root of both sides, and we have x plus 1 equals plus and minus root 13 over 4. Subtract 1 to both sides. Root 13 over square root of 4 is 2. Yeah, I've seen this part in your study guide. You might encounter a problem like this where you have to complete the square. So the problem would give you the x squared plus 3x and say, all right, what number do you need to add to complete the square? What number needs to be added in order to complete the square? So you take half of the number next to the x and raise it to the power 2. So half of 3 power 2 is 9 over 4. All right. Let's move to the next. All right, we got to use the quadratic formula to solve. So that means we have to start off by pulling everything to one side. So I'm going to start by pulling everything to one side, identify a, b, and c, and plug it into the quadratic formula. So here I plugged everything in. I identified a, b, and c, plugged it into the quadratic formula, and here I end up with this, which seems like it should be the answer, but it will not give you an answer like this on a test. You'll have to simplify this for sure. And 28, that's 4 times 7. All right, so remember that with square roots, you pull out the double. All right, so that's just like saying a 2 root 7. So let's see what happens when we simplify. So here I've simplified over here on the left, and hopefully that makes sense to you. If you need help with that, let me know. All right, next one. So I want to solve this equation for x, and so what I want to do is I want to pull the root on the other side, and I'm doing that because I want to get rid of the root because I want to solve for x, and so I want to raise both sides to the power 2 because when you raise a root to the power 2 you eliminate the root. So here we have x plus 1 squared. I'm going to pause it. Okay, so I've solved and I found those x values, and we would really need to plug back in here to see if those x values are legit. Remember that if you end up with a negative square root, you have to eliminate one of your solutions. Alright, next one. Okay, so part A, we have absolute value with an inequality, and really the fast, easy way of approaching these is rewrite the inequality without the absolute value, and then flip the inequality sign and change the number that's not with the absolute value to a negative, and you'll end up getting your right answers. Remember that whenever you divide by a negative, you got to flip the sign. Alright, so I found the solution with the inequality, but also I placed what that means on the number line, and I wrote the solution in interval notation. Remember, we go from left to right, smallest to largest, and the open circle means not including, which is the parenthesis. Alright, next one. Okay, so this next one, B, it asks what x values are going to be give us values that are greater than 0. Gosh, I wrote the wrong thing. Greater than 0. Okay, and so what I did is I had to first figure out where x is equal to 0. So I factored and I figured out that it's equal to 0 at 1/2 and 3. And then you can test values before and between and after to figure out where you're going to be in the positive and in the negative. And then from there you can identify your solution. We want to know what x values are going to be greater than 0, which means positive values. So we are going to go from negative infinity all the way to 1/2, including 1/2, and then from 3 all the way to positive infinity. Any value that you plug in from there will give you a solution that is true. It will satisfy this inequality here. I'll write all the solutions out right now. Alright, so I wrote all of the solutions up. I can't really talk about them, unfortunately, because I'm running out of my 15 minutes here. But let me know if this helps, and we can talk later. Alright.